the horizontal ellipse what we said yesterday was the big difference between circles versus ellipse is it's always going to equal 1, and it's usually going to be a fraction over here. And unless 1 is your denominator, which it could be, then you won't have a fraction. But most of the time, you'll have a denominator here. And on the horizontal ellipse, a squared goes on bottom, because a squared is always going to be the bigger value. And then the only difference between the vertical ellipse, the first part is always the same. But now a squared goes here and b squared goes here. So a squared always goes underneath. It's the bigger value. So if it's x, if it's horizontal, it goes there, and if it's vertical, then it goes underneath the line. And that's where we put a squared. Okay. The big pieces that we talked about yesterday were the vertices, co-vertices, and the foci. The vertices are always going to represent the A. How far are we moving it? We're going to move it A units to the right, A units to the left, or if it's a vertical ellipse, we're going to move it A units up and A units down. And then the co-vertices, B is always the smaller number. It's the shorter axis. And then the foci is a squared minus b squared equals c squared. Always remember that a is bigger than b. So your a squared value will always go here. And really basically just remember that you're never going to get a negative number when I subtract these. If I put 10 or 9 minus 16, then I'm going to get a negative number. And we don't want a negative number here. We're not going to get imaginary numbers when we deal with ellipses. So you should always put the bigger number first. And remember, it's not the Pythagorean theorem. It's a different formula. The only thing difference is we have a minus instead of a plus. Okay. These first couple, we're doing a lot of the same thing that we did yesterday. Yesterday, though, they just gave us equations, and then we used that equation to identify all the stuff, and then we graphed the ellipse. So a little bit different today. They're giving us the ellipse itself. We're going to identify all the stuff about the ellipse. We're going to write the equation for it and identify everything that we know. So the equation is probably going to be the very last thing that you do, even though I know it's listed first. We're going to identify all this stuff first, and then the equation will be the last thing that we'll finish up with. Kind of like yesterday, the first thing that we'll do in most cases is we're going to identify the center. And here the center is at 0, 0. And if you're not sure if it's the center, just count. Like in this case here, we go 1, 2, 3, 4, 5, 6, and we go 6 to the left, so we know it's centered right there between those two. Going up and down is 1, 2, 3, 4. Okay, and right there, that tells me my A value is 6, my B value is 4. So we want to count both distances. The bigger one is my A value, the smaller one is my B value. You can write this as two separate order pairs if you want. To make it a little bit easier, I just write it as plus or minus 6, 0, but remember that's two different ordered pairs. That's 6, 0, which is right here, and that's negative 6, 0, which is right here. So those are the 2 points that are on the x-axis. And that's the longer axis. The co-vertices go up 4 and down 4. So that would be 0 and plus or minus 4. The other thing that I'm going to do here is I'm going to write the a squared and b squared values. because those are the two values that are going to go into our equation. So I'm going to go ahead and square them and get that. I could go ahead and write the equation here. I'm going to go ahead and find the foci first, and then we'll finish off by writing the equation. Remember the equation, a squared minus b squared. And if we take the square root of 20, we'd get about 4.5. And it's also going to be on the x-axis. And it's always on the bigger, longer axis. And it's always on the inside of the ellipse. Sometimes it's further to the inside. Sometimes it's going to be almost right to the edge, like we talked about yesterday. But it'll still be on the inside. Okay, to finish this one out, using what we talked about up above, the equation. Because my center is at 0, 0 here, we don't need to put in an h and k value. So we're going to go x squared plus y squared equals 1. And this is my a squared and my b squared value. This is a horizontal ellipse, kind of like we did yesterday. We're always going to decide if it's horizontal versus vertical. It's longer horizontally than it is vertically. And so we're going to put the bigger number where? Under x or under y? X, yeah. So we're going to put 36 here, and we're going to put 16 here. If it was longer vertically, then we would put the bigger number underneath the y. Okay? Questions on that one? A lot of similar stuff to what we did yesterday, just kind of going about it a little bit different. Okay, let's jump down here to number 3, because number 2 is a vertical ellipse, but the center is at 0, 0, so it's not much different than number 1. Number 3, I think, is a little bit harder because it's centered somewhere else. It's not at 0, 0. And so the first thing that we're going to identify is what our center is going to be. And our center is going to go right 3, and then down 1, 2, 3, 4, 5, 6. So my center would be 3, negative 6. Okay, vertices. Now, vertices, and this is where you got to be kind of careful as well. I'm going to count 1, 2, 3, 4, 5. So I'm counting 5 over from 3. So this one is 8, negative 6. And if I go 5 to the left, that would be negative 2, negative 6. And you could just identify in the graph where they're at as well. So the a value is 5, which means a squared is 25. My b value is only going up 1 and down 1. So my b value is 1. And b squared would also be 1. Okay, my covertices are going to go up 1 and down 1 from my center. So my center was at 3, negative 6. So we're going to go up 1, 3, negative 5, and down 1 would be at 3, negative 7. The x values stay the same. The y values go up 1, down 1. Foci, 25 minus 1. So that's going to be almost 5, about 4.9. And this is one of those where I'm totally okay if you write it like this. My center's at 3, -6. So if I would go 3 plus or minus 4.9, -6. If you want to write both out separately, you can, kind of like I did these ordered pairs, but I'm okay if you write it like that. And all that does is tell me I'm moving 4.9 to the right, I'm moving 4.9 to the left, so it's just barely inside because my vertices moved 5, so 4.9 is inside, but it's barely inside. If I were to graph those two, they're like basically right up against the vertices because there's only 0.1 difference between those two. And so you hardly even see those foci on there. But it's still inside. And then my equation. Okay, once again, this is a horizontal ellipse. It's longer than it is taller, okay? And so the first thing that I always like to do is write out using the center. I kind of like to do that first. Use the center, write that out. It's always the opposite, so x minus 3 squared plus, always a plus sign in between, y plus 6 squared, since this is a -6, equals 1. And then I just got to decide which number goes where. Because this is a horizontal ellipse, the bigger number is going to go underneath the x, like the last one we did. So 25 is going to go here, and 1's going to go here. And if you wanted to, you wouldn't necessarily even have to put the 1 here, because dividing by 1 doesn't really do anything, right? So you could just write y plus 6 squared, and that would be perfectly fine. In most cases, that's probably what we would rather do anyway. But I always write it with fractions, filling it in, and so if you leave the 1 down there, I'm not going to count it wrong. Okay? All right, we're going to go on to next page. Number 4. Okay, this one even different, right? They don't have a graph for us. If you wanted to draw a graph, you could, but you don't necessarily need a graph to do this one. The hardest part here is we don't know the center. We know the vertices, we know the co-vertices. I need the center, so it kind of just goes through the steps here. We got to find the center first, use the midpoint formula if we have to. Vertices to find A, how far are we moving to get to A? And then determine what the direction of the ellipse is to determine where the A squared and B squared values are going to go. Okay, so first up, my center. You could do the midpoint formula, and I told you, I mean, you can, you don't necessarily always have to. If the center is somewhere other than 0, 0, you're probably going to want to do the midpoint formula. But here, if I did -5 plus 5 is 0, and 0 divided by 2 is still 0. And same thing for 0 and 0. 0 plus 0 divided by 2. So my center here is 0, 0. 0, 0 is halfway between -5, 0 and +5, 0. Okay, as I do this here, my vertices are moving 5 units either way. And because they're the vertices are always the A value. So we're going to say right here that the A value is 5, because that's my bigger axis. The vertices are always on the bigger axis. The smaller axis is going to be 2. It's only going to go up 2 and down 2 for the co-vertices. So that tells me that A squared is 25 and B squared is 4. We know that this is a horizontal ellipse again because my vertices are moving left and right. They're x values, right? So x values are moving left and right. Vertices are always on the bigger axis. So when we write this one out, we don't have a different center, so we can just do x squared plus y squared. The bigger number is going to go underneath x squared because it's another horizontal ellipse. And the smaller number is going to go underneath y squared. and that's our equation. Don't necessarily need a graph. If you're a visual person and you want to use a piece of graph paper, there's nothing wrong with that, but wouldn't necessarily have to use a piece of graph paper. All right, let's jump down to number 7. This would be one that I would say we would definitely want to use the midpoint formula for. I want to find the halfway point, and you can either do it for the vertices or you can do it for the co-vertices, because the midpoint of both of those is going to be the same. It's going to be my center, okay? But you don't have to do both. You just got to pick one or the other. And so I'm going to choose the vertices here. I'm going to go 5 plus 5 divided by 2 and 8 plus negative 6 divided by 2. 5 plus 5 is 10. 10 divided by 2 is still 5. 8 plus negative 6 is 2. 2 divided by 2 is 1. So if I really wanted to, our goal here is to write our equation. If we break this up into parts, I could start writing my equation right now. Obviously, we don't know a squared and b squared yet, but if you want to do it that way, or you could wait till the very end, and once I have all my information, I can do it then. But you can just take the information you have and start putting that into your equation, and just kind of do it in pieces. Okay, 5, 1 is my center. So here's the question that we got to ask ourselves. If I could go from 5, 1 to 5, 8, notice that the 5 stays the same, right? The x value is not changing. The y value is changing. So I'm going to go from 1 to 8. How far do I have to move to get from 1 to 8? How far? 7, right? So my a value here is 7. And I know it's my a value because it's a vertice. Okay, vertices are always the bigger one. And so I know immediately that's my a value. It should also be, like if I go from 1 to negative 6, that's going to go down 7, right? So we're going to go up 7, we're going to go down 7. Should be 7 in both directions. So it doesn't really matter which way you count. The easier one would do the positive one. Okay, then we're also going to do the co-vertices. So if I go from 5, 1 to 11, 1, 5 to 11, we're going to move 6 units. Once again, B should be smaller than A. If B is bigger than A, something's wrong, okay? B has always got to be the smaller number. A squared is 49. B squared is 36. Okay, now here probably comes the most important part. Where do those two numbers go? Well, my vertices are going up and down, right? Because we're moving from 5, 1 up to 5, 8. So since we move up and we move down to get to my vertices, this would be a vertical ellipse. Vertical is up and down. That's my y-axis, right? So the bigger number is moving up and down, which is the y-axis. So 49's got to go here. 36 has got to go here. Okay, any questions on that? How we decide which one goes where? Does that make sense? But that's a really important part, is identifying which one, if it's vertical, if it's horizontal. Okay, let's jump down to number 8. Okay, each one of these is giving us different pieces of information. We, on the last one, had vertices and co-vertices. This one is vertices and foci. On the last one that we're going to do, number 10, we're going to do co-vertices and foci. Okay, so we're doing something different on each one. Once again, we always want to find the center. Center is usually our starting point. 0 plus negative 10 over 2, 6 plus 6 over 2. So that would be -5 and 6. And we can start putting that into our equation. Okay, we're always moving from the center to these. One of the numbers should be exactly the same, okay? In this case, the y value is the same, so I'm not moving the y value at all. The x value is the one that's moving, and the x value, to get from -5 to 0, and from -5 to -10. So we're going to move right 5, we're going to move left 5. So my a value is 5. And we know that it's the a value because it's the vertices. Vertices are always the a value. Now this one's different. On the last one, we did a and b, but foci gives me the c value. So this is where you got to be a little bit careful. To go from -5,6 to -2,6, or -5 to -8, whichever way you want to go, should be the same either way. -5 to -2 tells me that my c value is 3. We just got to count. Think about a number line. If I go from -5 to -2, how far am I moving? Or -5 to -8. Should be the same number. If it's not the same number, that means my center is probably wrong. A squared is 25. B squared is 9. Now remember when we do the formula here, we got to have a squared and b squared, and right now we don't have b squared because we aren't given the covertices. So we have to find b squared. So we're going to go back to this formula again. We know a squared is 25. We know c squared is 9. And then we got to solve for b squared. Easiest thing I think to do here is add b squared to one side, subtract 9 from the other, and I get b squared equals 16. And I don't really care what b is. I just really need the b squared value. So b squared is 16. Okay, the last thing we got to decide is what number goes where. The two numbers that we're going to use are 16 and 25. If I go from the center, -5, 6 to 0, 6, what direction am I moving? Horizontally or vertically? Horizontal, right? We're moving left and right because my x value is the one that's changing. So this is a horizontal ellipse, which means the bigger number goes underneath the x and the smaller number goes underneath the y. Okay, don't put 9 into the equation. That's a pretty common mistake. 9 represents, I wrote b squared up there, didn't I? You guys got to keep me honest here. What's Mr. Ruda doing? Sorry about that. You guys are probably confused by that, huh? I got in the habit of writing b squared and I went ahead and wrote it. All right, questions on that one? Other than the mistake that I made? Okay. Last one we're going to do today. Covertices and foci. Covertices and foci. So we're just given different information each time. This one's a little bit harder because we're not given the vertices, which is our major axis. So we got to remember that this is our minor axis. But which axis do the foci always land on? Long one or short one? The long one, right? So the foci will always land on the long axis. The covertices are always on the short axis. So if we're looking to figure out what type of ellipse we have, the foci will be on the same thing as the vertices. All right, so once again, center. Halfway between 5 and -5 is 0, And so my center here is 0, 0. You can do your midpoint formula if you want to, but halfway between 5, 0 and negative 5, 0 is just 0, 0. All right, covertices are the B value. Foci are the C value. So this time we're finding B and C. We don't know A. We'll have to find A. To move from 0, 0 to 5, 0, we know the B value is 5, which means B squared is 25. To move from 0, 0 to 0, 12, we're moving 12 units. So C squared would be 144. We don't have a different center here, so it's just x squared and y squared. And we're going to take the two pieces of information we know. We should know two of them, right? We're always going to give you two pieces of information, and we got to find the third. We know B squared, we know C squared, so those are going to go in for those two values. So we're going to go 144. A squared is what we're trying to figure out. We're going to add 25. A squared is 169. Okay, once again, we got to decide what type of ellipse we have here. So if I go 0, 0 to 5, 0, that is 5, but that's the shorter axis. Up and down is the shorter axis. The foci, oh, sorry, we went left and right. The foci are going up and down, and we're going up 12 and down 12. The foci land on that longer axis. So this is a vertical ellipse. And vertical tells me the bigger number, A squared, goes underneath y squared, and B squared goes underneath x squared. We never ever put the foci into the equation, so don't ever put C squared into the equation. It's always A squared and B squared. All right, guys feel good about all that? Just a little bit different direction than what we did yesterday. All right, homework for today. We're on the third page of the homework packet, homework 3. It's labeled at the top, homework 3, writing equations of ellipses. 1, 3, 4, 6, 8, and 10. Yeah.